Great to see you here again in this new video offered to you by the Custer Academy. My name is Luc de Custer and welcome to my YouTube channel. If you're here for the first time or you didn't subscribe yet, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. In this video, I'm going to look at something special because we looked at the normal distribution, we looked at the average and the standard deviation. Now here we're going to look at what we call the standardized values for the Gauss curve. And it understand where this basically comes from. When we look at the history, people didn't have the computer, didn't have the calculation or calculators and calculation power that we have today, and people had to work with tables. And what they did, instead of creating, which was impossible, creating tables for any average and any standard deviation, they created a new kind of normal distribution based around around 0 and a z value which is basically saying how many standard deviations that you are to the left or to the right. And basically when we look at the standardized population data, let's say we have a value of x that I want to evaluate. We have an average of mu, which is 145, and a standard deviation of 5. When we bring the numbers to 0, we replace in fact x by the number of standard deviation it's to the left or to the right of the average. And we do that by x minus mu, subtracting mu from x, and dividing it by sigma, by the standard deviation. So what we have here, we have 157 minus 145, that's the distance between the average value and the x value, and we divide that by the standard deviation. So we find here 2.4. This means that x is 2.4 standard deviations to the right of the average, in this case 0. And we're building the normal distribution around 0. Now whatever the average is, whatever the values are, the standard or the normal distribution always gives the same percentages. Now instead of calculating all those tables with x and mu and sigma, we just create a table displaying the z value. We can do that also with standardized sample data. Instead of using mu and sigma, we use x bar and s, and basically the calculations would be the same. So what we are doing, we find the numbers, and now we can say, well, the point x is so many standard deviations to the left or to the right. The z value can be positive when x is to the right of the average, and the z value is negative when x is to the left of the average. Now basically what we want to see, we want to find out how do we do these calculations, and we have different types of tables that have been developed. We will look into that in the next video. So we have to identify which table are we using, but also we can use all those calculations. We can use predefined formulas in spreadsheet programs or in special programs for statistics, but also, for example, in Excel or any other spreadsheet program. Well, we look at the element here. Now we have the normal distribution with the average equal to z, 0, and the z, for example, the element here. Now what we find in the table of the z-scores, we find two possibilities. We find the surface between 0 and z. We will recognize that table when the z value is equal to 0. It means we are on the average. We find that in that case the percentage is equal to 0, and that's what is represented here. Now this is the z value. We find that in this table, but there is a different type of z or table, a standardized normal table that we can use, and that has also that 50% included. So when we see that the z value, z equals 0, gives you a percentage of 50%, then we are measuring everything from z to the left. So we have the surface that is gray here plus the 50%. You have to recognize the different types of table and find out what is happening here. Now, when we look at the element, when we want to know the percentage to the left of z, and we have a table where we have z equal 0 gives you 0, in order to find the percentage to the left of the z value, we have to add 50%. And this percentage is read from the z table. We can find it in the standardized normal tables, and we will do some exercise on these tables. So you will understand how it works, and we will also have a look how it works with the formulas of Excel. The z-score, depending on the elements that we want to have, we have different questions that we may have. We may find here the percentage of all values smaller than x. Now, let's say we have the two tables. We have the table measuring the z values, everything to the left. So the table where we find z equal to 0 gives us 50. Then we don't have to do anything. We just have to look at the z value. But it's possible that we have the table where we only get the distance or the percentage between x and the average. So in that case, we have to take that z value, the percentage corresponding with that z value, and we have to add 50%. In some cases, we want to know what's the probability that my data will be between two values. And what we have to do here, we have to look at those two values. We have two, let's say, graphs that we have to consider. We have to consider a first graph with the surface for all values smaller than x2. We do the same for all the values smaller than x1. And then we subtract those two values, and we find the percentage between x1 and x2. Another element we can have those negative values, and when we have a table where we have, in fact, for z equal to 0, 0, so we don't have negative values in that table. If we have a table with negative values, we can read automatically what that surface is. If we don't have it, well, we can say that the surface between or to the left of x is equal to everything to the left of mu minus the surface between x or mu, which is, since we have a symmetrical distribution, is the same surface between mu and x. So basically we're going to take the surface corresponding with the absolute value of the z value and subtract that to the 50%. Now when you look at it, because it's symmetric, when we look at x at the last graph on the bottom here, the surface from x to the left is the same as the surface from x. When we look at this distribution, we have another element that we can say, like we said, okay, it's a symmetrical distribution. So when we put the value of x, the same distance, to the right of the average, the right of mu, we see that the white zone to the right is basically equal to the gray zone that we wanted to calculate. So the values, the surface for x smaller than, or the value smaller than a certain value x, is equal to the opposite side. So we can basically calculate that same value. So these are some ways how to do the calculations. We will look into that deeper when we do some exercises, and it will be easier for you to understand how these work in reality. Thank you very much. Don't forget to click the subscribe button. Don't forget to click the bell button. And I'm looking forward to seeing you in the next video. Thank you and bye-bye.